Thank you so much for joining, Shihan. Um, Super excited to just talk about your background expertise. I know it's a little bright.
Thanks so much for having me.
Yeah, for sure. So we'll just kick it off. Why don't you tell us a little bit about yourself and your interests?
Yeah, sure. I'm currently a final year PhD student in computer science department at the University of Southern California. I work with Dr. Heather Carlson, and I mainly focus on robotics with expertise in haptics, the sense of touch. I'm trying to combine the sense of touch with robots to give them more fancy abilities to interact with our environments.
And you had told me when you came in that it's actually National Robotics Month, right?
Yeah, this is the National Robotics Month. At USC, we have a special robotics open house. Everyone's welcome to visit our lab if you're interested.
For sure. I was telling Shihan that you should have brought one to show. So you're currently working, as you said, in the Haptics, Robotics, and Virtual Interaction Lab, which explores how humans interact with our world, robots, and technology through touch. During your time, what kind of projects are you working on, and how has your understanding of human and robot relationships evolved?
Yeah, sure. Currently, our lab or my work has two focus. The one of the focuses is about how can we bring the humans to create the realistic touch sensations for humans, so that they can interact with the virtual environments with more immersive and realistic experience, or the magic word metaverse. How do you feel the different objects through touch in the metaverse? And the second focus of our work is how to equip the robot with the human-like or even superhuman touch capabilities, so that the robot can conduct some tasks with in a more robust and efficient ways.
And you worked on a paper titled Active Acoustic Sensing for Robot Manipulation. Can you describe for us and our audience here what were kind of like the findings and conclusions in terms that we might understand?
Yeah, that project kind of traditionally for the robot design, no matter in the sensing, action, and the reasoning aspects, that's the three basic elements of the robot design. In each aspect, we are always trying to follow the biology from the human side. For example, when we're designing the sensors, designing the touch sensors, we're trying to mimic the touch capabilities of the human's fingertip. We're trying to give the robot the same capability as our human fingertip. And for the action side, when we're designing the 7 degrees of freedom robot arms, we're also trying to get closer to the human arm's dexterity. And for the reasoning, which is a popular one these days because of the AI vibe or the AI trend, we are also designing our reasoning algorithms based on how the neurons are processing the stimulus in the human brains. So this type of biological inspired design has been in this community for a very long time. And in our recent work, we're actually doing this robot design more from a numerical, more from a data-driven approach. We're not closely looking to the biology of the human side. We are directly looking to the large data we collected through the interaction with the environment, and then try to get the algorithms designed out of those data directly. And we just found that in that way we can design some superhuman touch capabilities that humans do not have, and it actually worked out pretty well. So that really gave me the thoughts that how do we get the best out of both sides, from the bio-inspired design and the data-driven design. And yeah, that's my thoughts about that project. And well, in the future, we do want to find a a better way to combine the both sides and create more interesting stuff.
In the film that the audience is about to watch, called After Yang, there is a family with a robot companion named Yang. Based on your own studies, what might be the challenges of a robot like fully integrating into familial life, which might be a thing in 50, 60 years?
Yeah, I do believe so. And actually, like about 10 years ago, when I first raised some interest in robotics, that's the time that the autonomous vehicle is super popular, and everyone is talking about that. And they do believe that autonomous vehicle is going to be everywhere in 10 years, which is about right now, but it's actually, it doesn't happen yet. At that time, there the theory is like, if we can replace all the vehicles on the road with autonomous vehicles, and then our traffic will be way much better and safer. But the problem is like, will people give up their rights of driving? I don't think so. Lots of people enjoy driving at some point.
Yeah.
So
we do a poll. Who would like give up like driving to just have autonomous vehicles everywhere? Yeah. But who's like, I want to drive? Oh.
Yeah, so we're trying to get this research community and trying to get this balance. It's like there are some autonomous vehicles out there, and also there are human drivers around those autonomous vehicles as well, right? And this ratio it sounds trivial, but it's actually quite critical because the autonomous vehicles has to change their behaviors based on how many human drivers around them. So that requires the robots. The robots here is the vehicle. It has ability to adapt to the environment or adapt to the different driving behaviors from the humans. And that is still kind of like a key questions when we are really try to deploy a large amount of autonomous vehicles out the world.
Yeah.
Yeah.
It's hard.
And I think that's very challenging. Yeah, as you said, it's hard. But in the next 10 years, maybe there will be more and more autonomous vehicles out there. And I'm also excited to say how can we create the rules and even laws behind those deployments.
What is your outlook on the future of human and machine relationships as the technology progresses? Are there any particularly fascinating advancements being made in the space that you think will affect our day-to-day? I know you talked about autonomous vehicles, but is there anything else out there?
Yeah, there's a very strong trend in the robotics community these days. Is about a home assistive robot, either social assistive or physical assistive robot. Those are two major domains. When we're trying to put the robot in our home, the socially assistive robot is about how the robot can give us emotional support when we really need, and the physically assisted robot is to help us do the task that we don't want to do. Then we can to spend more time on the things we're really interested. So on the generally in this home assistive robot, I think these days one of the biggest challenges is like everything in our daily life in our house is designed for the human use, even from a water cup to the laundry machine. To everything is just through a small door through the door handle. Everything is designed for the human operation, for the human manipulation. So, but that is just poses lots of questions for the robots, because the robot's hands is not that sophisticated as a human hands, which is hard to rotate a door handle robustly as we did. So when we're trying to really put the robots in our home, we're also trying to make a negotiation, just like the autonomous vehicle and human drivers. Are we trying to produce more product that is suitable for the robot use? Are the industry product industry behind those products will make such a negotiation. That's just brings up lots of key questions in the whole industry. At this point, I don't think we have an answer. Yeah, I think hopefully in 10 years we'll figure out if really we're willing to make such a, for humans, we're kind of like making such a sacrifice that we can bring the robots to in our home and do the task for us, but some objects or even some functions are specifically designed for the robots, but not for the humans.
Any closing questions for Shihan here before we get started? That's such a great precursor into After Yeah and Guess.
Yeah, definitely. Actually, I would say it's like because I have worked in this robotics community for a while, and I'm really constrained by the stuff in this community. I have to admit it's very hard for me to think really loud out of this box. So the movies really just constantly gave me a lot of inspirations. If you ask me one or two movies that inspired me most, I would say E. It's definitely the movie that inspired me a lot. The old movie.
Which is it?
Sorry. The Wall-E.
Wall-E.
Wall-E robot. That's, I think most people like it.
Yes.
The second one, I would just say Transformers.
Yeah.
But that's...
They're all robots. I love it.
I kind of hate to say that, but I have to admit, yeah.
I love Transformers. I love Wall-E too. Awesome. Any last question?
Yeah, the usage of the tactile sensing, traditionally we only have when you are trying to grasp or manipulate the object, the current sensor widely used in either industry or in research is just about force feedback. That is, we call it a modality in touch because the touch, if you think about the touch, when you are touching a surface, you feel the temperature and you feel the pressure. And when you are sliding across the surface, you feel the high frequency vibrations. And also, the fingertip is deformable. You feel the deformation of your fingertip. Each of these signals, we call it a modality. And currently, the really mature sensor we have in the industry and in the research is about the force feedback, the force sensor. And for other modalities, like thermal feedback, vibrotactile feedback, and the stress and the strain feedback, all of those are, we do not have unlike a camera, we don't have a standard sensor designed for each specific modality in touch. So, but obviously, each modality is useful, depends on your downstream task. So, I hope that answered the first question. And the second one is, for me, I think what makes the touch sense really unique compared to the other sensory modalities is like I would say it's hugely depends on the human's preference because the thing you feel that are probably are warm that are probably not that warm for the others. Similarly, if you feel something is really stiff, which is probably not that stiff for the other humans. So that properties just makes the haptic sensing has to be like adaptable and adjusted to the different human preferences when they are we're trying to put them in the real cases. Unlike the vision, which is a huge research community back there, vision is more consistent, but vision is compared to the touch is more vulnerable as well. Different lighting conditions, occlusions, blur, all of those will affect the vision, but those problems is kind of non-existent in the touch community right now. So yeah, that's why we are kind of pushing the boundary of the touch sensing at this point.
Yeah. That's fascinating. Well, thank you so much for sharing, Shihan. Give it up for him.